Hello, in this video we will use LINEST, FV, rate, NPER, PMT, PV in polynomial regression for loan balance payment calculation. Here we have a loan balance, a credit card loan balance of $10,000. We denote it at negative sign, so 10,000. And the interest rate of the credit card is 20%. So we will show the data set for our trend line of our credit card balance for the next 15 years. So we have RA formula, FB, and the rate will be 20%. The number of periods will be this range, and the payment will be this cell, which for now it's zero. We don't know how much to pay. And the present value is 10,000. And we'll just make payments every end of the period. So it's zero. So our credit balance rises from 10,000 to the present value, 254,000. We will show the data set, the trend line of this. So we use scatter chart. And this time we will use the trend line as polynomial. And we want the maximum, the higher degree, so that we'll have the better fit. And you see our credit card balance rises from 10,000 to 254,000 on the 15th year. That is, if I don't make any payments to the credit card. How much payment will I make every year so that the balance of this credit card will drop to zero? So we'll use the function PMT. PMT, the rate, and then after the rate, the number of periods. We'll choose 15, the last period, and the present value, which is 10,000. And the future value, we want it to be zero. So 0, and because we're paying at the end of each period, that's also 0. So we need to pay every year $2,138.82. So we will enter that amount, 2,138.82. And it should be positive because we're paying the credit card. So you'll notice the balance is now 9 cents from 10,000 to the current year to 9 cents on the fifth year. We will show the trendline equation of this. To do that, we will choose the chart and choose the trend line, the series for the trend line. We'll use the polynomial and you show the value of the equation and the r squared as well. So here we have our B0, which is 10,000, 10,058. Our B1 is minus 226. Our B3 is 16.9. Now that's our B2. Our B3 will be minus 3.08. These are the values. That's B0, B1, B2, and B3. We will calculate using LINEST, but we need to get the coefficients x1, x2 squared, and x3 squared. So we have to calculate this, fill up this matrix. We start with the 1 column, followed by the x column, which is RA formula of the x values. Our x values will be the NPER column. and the x squared, which is equal to RA formula of the x to the power 2. And the x cubed column will be RA formula of the x column to the power 3. Now that we have factored out and filled up the 1 comma x matrix, we can now use the LINEST. We have LINEST of known data y, which is will be our data y, and the data x will be these three columns, and we show the full statistics. So our b0 matches to our equation 10,058. Our b1 negative 225.85 is rounded up as negative 226. Our b2 16.929 is rounded off as 16.9 in the equation, and our b3 is negative 3.083 rounded off as negative 3.08, and our value for r squared is 0.9998 is rounded off as 1. This completes our polynomial regression for loan balance payment calculation using LINEST and the financial functions.